All right, so shall we begin? Are you guys ready? Let's go. Okay, so before we even talk about what algebra is, I know some of you are going to be curious about what algebra is. So before we even talk about that, I'm going to talk about something called visual thinking. Okay, visual thinking meaning that we want to imagine the situation. Like there's a question in maths, there's a certain scenario. You want to be able to imagine what is happening visually with pictures, or you can either draw them or in your mind. Okay. That's before we actually get into what algebra is. Okay. So today we're going to discover how visual models can actually make solving questions easy and enjoyable. All right. So it turns out that the lions also like ice creams. You know why? Because there were
Why?
only three of them and they ate 30 ice creams. That's a lot of ice creams, right? Sir, the shop bill says that 30 ice creams were eaten in total. So there were only three lions and they actually ate 30 ice creams altogether. Okay, so now how does this relate to algebra here? Okay, we're trying to actually find out how many ice creams did each lion eat? Okay, the shopkeeper also told us that each lion ate an equal number of ice creams. Okay, this is an important information that the shopkeeper told us. So look at this visual diagram here. Look at this picture. We've got a picture of a lion. So that's one lion, right? Then we've got another lion here and another lion. So we've got three lions in total, okay? And this picture actually tells us how many ice creams each lion ate. But we don't know the number, right? We only have a picture over here. So how many do you guys think? I want you guys to guess. How many ice creams do you think each lion ate? Perfect. So you're actually dividing by three. So the idea of division in mathematics is, let me remind you guys that whenever you do division in mathematics, it's equal division. Did all of you know that? Okay, and I'll repeat, anytime you're dividing in mathematics, you're actually dividing equally. So if I take 30 ice creams and I divide them equally and I divide them among three lions, I'm always dividing it equally. It's fair, it's even, okay? Every lion will get the same amount. So when I do 30 divided by 3, I'm actually getting 10. And you guys actually got that answer, right? If each lion ate an equal number of ice creams, then each lion actually ate 10 ice creams. Now, we're actually going to now talk about what algebra is. So this was something related to algebra. We'll actually come back to that example later when we introduce to you the concept of algebra and also the concept of visual drawing. Okay? So what do you guys think algebra is? I'm sure some of you have heard about this word before, algebra. Any idea what it is? So I'll tell you what algebra actually is. So algebra is basically a branch of mathematics where we use symbols. You might have seen something like X, Y, or Z in mathematics. And if you look at maybe your older brother or sister's textbook, you might have seen something like, why do we use those letters? Well, we use them to represent unknown values. Just now, remember how we used the picture of a lion? Because we didn't know how many ice creams each lion ate, right? So we use the picture of a lion. In algebra, instead of drawing that picture, we actually use symbols. But in this presentation today, we're mostly going to be using pictures instead, okay? Pictures and also the bar drawing, which I'm going to introduce to you guys now. Okay. Or after this one, where we'll talk about, okay, real life uses, just what are the real life uses of algebra? There's actually many real life uses, but you need to get the basics first. Some of the uses are figuring out how much money is remaining after shopping, the number of items in a box, or also, as we saw in the earlier example, how to actually split things equally, okay? Keyword equally. So those are some real life uses of algebra. Of course, algebra extends beyond the math class as well. We use algebra in coding games, in solving puzzles, and also planning events like birthday parties. All right, so the main topic, or one of the main topic of today is using model drawing in algebra, okay? That's the whole point, right? We're trying to visualize the information by actually drawing a model drawing. So let's see what kinds of model drawings that we have and how we can actually use them to help us solve questions. Okay, so first of all, okay, it turns invisible math ideas into pictures and drawings that you can actually see. So if you have a word problem, right? I know a lot of students, they don't like word problems. Word problems look very difficult. There's so many words, right? That's why they're called word problems. So the idea is that we're going to take all the information one by one from there. We're going to draw some models, okay? And from those models, we're going to be able to see visually and we're going to be able to understand what's actually happening and what the question actually wants from us, okay? And of course, like I said, word problems sometimes can be very lengthy. So it helps us to tackle complicated problems one step at a time. So we're going to draw one model one step at a time, and then that is actually going to help us to solve or break down the problem, okay? And of course, it is going to build confidence. This one I can guarantee if you practice model drawing, you will actually feel like a math superhero because later on, once you practice drawing enough, you won't even have to draw on a paper. You can draw in your mind. Trust me, this works. You're going to be able to draw these models in your mind and you're going to be able to solve the question entirely in your mind. So that is how it's going to help build your confidence. Okay? So are you guys ready for some model drawings to see how it works?
Yeah.
Yes, okay. All right. So the first type of model drawing that we have is called the part whole model, okay? We're going to have one bar to represent the entire thing, the whole, and then we're going to have some models within that bar to show part of that bar, okay? So we're going to use that part whole model. That's the first type of model that we're going to use to represent the total as a sum of its parts, okay? So again, the words, you might not understand exactly what it is, but when we look at it visually, you'll be able to see what that means. Okay, so we have our first example for this kind of a drawing, which is this one. Okay, I'm gonna read it for you guys here. We've got Frogsy the frog who lost 6 flies. Okay, so he had some flies at the start. Okay, Frogsy, and then he lost 6 flies. Okay, once he lost 6 flies, he now has 9 flies left. Okay, so the question is actually asking us, how many flies did he have originally, or how many did he have at the start? I want you guys to think about this. Okay, anyone, any idea? So he had some flies at the start, and then he lost 6 of them, but he still has 9 remaining. So how many do you think he had at the start? Anyone, before I show you the solution?
Do we have to plus?
Yeah, this is the problem, right? We are not sure if we have to plus or minus. Sometimes it's confusing, right?
Yes.
Hmm. So this actually model drawing is going to make us confident whether we have to plus or minus, okay? So let's see the solution here. By the way, you are actually right. We do have to plus, but why? Let's see why we have to plus it, okay? So we're going to draw one bar. Actually, this one is supposed to be one bar from all the way from the start to the end. And that is the whole. Do you guys know what whole means? Whole means the entire thing, right? Okay, whole means how many flies did Frogsy the frog have at the beginning? That is something we don't know. So we're going to draw one bar from here all the way to here to represent that. And then within that bar, we're going to make two groups, okay? The amount of flies that he lost and the amount of flies that he has remaining. So since the question told us that the frog lost 6 flies and then had 9 flies remaining, yes, to find out the total number, both of those boxes make the entire bar, right? Yes, exactly. We need to add. So we need to do 6 plus 9, okay? 6 plus 9 equals to 15. And from there, we understand that the total number of flies that Frogsy had was 15. Now, let's see how we can actually write that as an equation instead, okay? Remember, I mentioned that in algebra, we use symbols to write down unknown quantities. So in this case, the unknown quantity was actually the total number of flies, right? We didn't know how many flies that Frogsy had. So we say that let X be the total number of flies. And then because he lost 6, right? 6 of them, imagine that they fly away. So what happens when you lose something? You're supposed to minus it, remove it, right?
Minus.
Yes, so the flies have gone away. So from that total number, whatever that number was, 6 of them have gone away. And then how many are remaining?
9.
9 are remaining. So we can actually form this equation. This is called an algebraic equation where we have a symbol instead of a number. Okay. So we've got x minus 6 equals to 9. And we know, okay, what number when you minus away 6 gives you 9? That's what we just found, right? 6 plus
Yeah.
9, that gives us
15.
15. So hence, x equals to 15.
15.
Okay, so we've got Tiger Tim here who spent some amount of money. How much? Well, he spent
$45.
$45. That's a lot of money on bubble tea. So he spent $45, but he still had some amount remaining. He didn't spend all of his money,
He
right?
had $30 left.
He had $30 left. So now the question wants us to draw a bar model for this. So I'm going to actually take this question over to my whiteboard and we're going to draw a bar model together. Okay?
Okay.
All right, let me copy down the question here. There we go. Yes, it should be 20. So once again, because the keyword here is that each unicorn had an equal number, so we're going to divide, right?
Equal is
Yes, like I said in the beginning, right? Division is always equal in mathematics, okay? So let me share with you guys the solution here. So we're going to draw a bar to represent all the carrots, and then we're going to split it into 3 sections. Why 3 sections? Because there are three
because there are
unicorns,
three
right?
unicorns.
Yes, perfect. So each a little bar over here, each of these boxes, let's say, it represents how many carrots did one unicorn eat. So right now we didn't know this 20, right? So right now we don't know this 20. So, but what we do know is that the total number of carrots is 60. So we're going to represent this entire thing by 60. So that's 60 carrots. And then we have split it into 3 parts because there are 3 unicorns. So whenever we're splitting something equally, we're supposed to do division. So here we're going to do 1 unicorn gets 60 divided by 3, 3 units, right? So that comes out to be 20, as you guys are saying. So that means now we can actually write down the equation. We can write it down like this. So 3 units or 3 unicorns. So 3u equals to 60. So look at this. We're using a symbol here, right? We're actually using a letter. We're using the letter U to represent the unicorns,
Units
okay?
or the unicorn.
Or yeah, in general, we actually use it for units. That's correct. But in this case, okay, we can think of it as U representing, yeah, 1 unicorn, right? How much did 1 unicorn eat? So because
20.
here we have, yes, we need to do 60 divided by, so
60
let's do this
divided by
one,
3.
60 divided by 3, and that gives us
20.
20. It means that each unicorn ate exactly
20
20 carrots.
carrots.
And then once we find this answer later on, we can fill in these boxes. So this is 20, 20, and 20 because we want to confirm our answer, right? How can you make sure that your answer is correct? How do you make sure that the answer is right? You can check this one, right? This is 20, 20, and 20. So you do 20 times 3, right? Or you can do 20 plus 20 plus 20.
20 plus 20 plus 20 equals 60.
Correct. So repeated addition is the same thing as multiplication, right? So if I have so many times 20, I'll just times it, right? So 20
Yeah, times
times
is
3. Yes, and that gives us 60.
60.
So this is the same as in the question, meaning that we got our answer correct. Okay. So now let's take a look at another example. Without the solution, I will let you guys try it. Okay, like another one involving the same kind. Okay, actually, we'll do this on our whiteboard. Okay, so this is another same type of example using a unit model. Okay, so let's read the question first. It says 5 robots used 100 volts. Do you guys know what volts is?
Uh, is it electricity?
Yes, it's something to do with electricity, right? So how much volts? Volts is a unit. So how much volts are each or is each robot using? That is going to be our goal. But what we do know is 5 robots used 100 volts, and we're going to assume that each robot used an equal amount, okay? Yes, there we go. So we're supposed to do 100 divided by 5. Okay, but the question says draw a unit model, right? Remember, that is our objective for today. We're trying to draw a unit model. Okay, the answer is actually correct, but I'm going to show you how to actually draw a unit model for this. Okay? So once again, let me copy down this question to my whiteboard and we're going to draw a unit model for that. Okay? So the important thing is you always read the entire question, okay? I know sometimes it's very tempting to just see the numbers and quickly do the division or the addition, but we have to be careful, okay? We need to read the entire question. What exactly does the question want from us and so on, okay? Okay, so let's see what else we have. Okay, the last part is actually going to be on forming visual models to, or from visual models, moving on to actual abstract equations, okay? We're going to bridge the gap from visual representations, the one that we just saw, moving over to actual algebra involving X, Y, etc., okay? So we're going to emphasize the progression from pictures to symbols and then finally on to equations, okay? Equation just means like a mathematical equation where we have an equal to sign. You can have something plus something equals to something. That is what we call as an equation. So, like I said, we'll come back to our very first example. Okay, the 3 lions that they ate ice creams, 30 ice creams altogether. So this is the very first one that we talked about, right? This is the visual representation that we gave. So we drew a lion and then another lion and another lion to represent 3 lions. And because that wastes a lot of time, right? We cannot draw a lion every single time we want to solve a question in the exam. Then you cannot do all the questions, right? So because of that, we can actually simplify it instead to like a box, something like 1 square, okay? So we can draw 3 squares and then we can say that all 3 of them added together equals to 30. Or if we want to make it even faster, okay, if we want to make it even faster, we can represent the number of ice creams that each lion ate with a symbol, such as L. Okay, we can do something like L plus L plus L equals to 30. Okay. And because you guys know that repeated addition is the same thing as multiplication, right? So we can actually write that as 3 times L. Remember, L just represents a number that we don't know yet, okay? We don't know what L is, that we don't know the number that L represents, so we're going to write that as a letter for now. So 3 times L equals to 30, and you guys were able to figure out earlier, remember? What should L be equal to here? So L should be 30 divided by 3, right? 30 ice creams divided by 3 lions. So L comes out to be, how much was it again? Please remind me.
And
10. So this is basically what algebra is. It's moving on from pictures. Suddenly now we're, well, not suddenly, but we're moving on from pictures to letters or symbols instead, just to make our working a little bit faster, okay? So it means that L, the number of ice creams that each lion had, was simply 10, okay? So far, what have we discussed? We've discussed the part whole model and we've discussed the unit model, and now we're actually moving on to algebra equations, right?